Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hsta bin Nordin. So today we will present about the mini project for ECS 338. So we are working as an assistant engineering at Hsta Manufacturers Sdn Berhad that specialize in structural steel design. Our company were assigned to propose a design of an open space industrial structure. So in this project, we will determine the ultimate vertical loads on the roof truss and RC floor, then propose suitable size or dimensions for steel beam at 1/B to C, steel column, and a beam column connection by conducting appropriate checking on SDC. And lastly, we will draw the detail of the frame by using AutoCAD. So I will pass it to Muhammad Taqiyuddin to tell more about ultimate vertical load.
Okay, thank you, Hsta. My name is Muhammad Taqiyuddin bin Mahat, and I will present to you about the ultimate vertical load. First, we have ultimate vertical load on roof truss. In this case, we get the case 5, which is N is 8 meter, N is 8, S is 2 meter, and the B is 5 meter. And for the GK thrust, I get at the question, which is 0.2 plus 0.3 kilonewton, which is the steel roof sheet is 0.2, and the safe weight of thrust is 0.3, and the QK of thrust, roof thrust is 0.5, and the design action is the 1.35 times with 0.5 plus 1.5 times with 0.5. As shown at the ultimate vertical load on roof truss um, at the poster that has been shown. Okay, next I will tell about the where the load is acting. For the 15.94 kilonewton is acting on the roof of its truss, and for the end to end of the load is we divide by 2, which is 7.97, that has been shown at the calculation. And after that we get the reaction for the to get the column to transfer to the column, the load to transfer to the column. And after that uh, I find the ultimate vertical load on slab, which is Ly over Lx is 8,000 over 5,000, and the slab is 3 edges continuous, discontinuous, and 1 edge continuous, and the permanent action on the slab has given, and after that I find the design load for the slab, which is that have two design load, W1 and W2. W1 is acting at the long span Lx, and the short span L, L, Lx for W2, and W1 is long span Ly. Next, I will pass to the Syed Faiz.
Okay, for the steel beam design and steel column, I, Syed Muhammad Faiz bin Sulaiman, take part of this design. Okay, first, I design for the steel beam design. The size that I've got is 305 times 102 times 33. Okay, this is based on the catalog that we search, and the dimension provide is that one. So first one, the load, calculation of load, it comes from the slab, from the surface of slab that we calculate just now. And then we find the bending moment and the shear force that I've got. The MED value is 125.76 kilonewton meter, and the VED is 62.88 kilonewton. Okay. And then for the selection of section, I got from the catalog, and I list up what we need in this design. And then step number 3 is classification of section for web section and flange section. Okay, for the web section is categorized as class 1, and flange section also in class 1. Okay, and then we can conclude that beam section is class 1. And then for bending moment and shear force resistance, the MED must lower or same with the MPLRD. So I've got that MED is 125.76 kilonewton is lower than MPLRD, that is 132 and 28 kilonewton meter. So bending moment resistance pass. Next, VED must be lower than VPLRD. And then after I calculate, the value of VED is 62.88 kilonewton, is lower than the VPLRD, 305 and 04 kilonewton. Shear force resistance also pass. And then shear buckling also pass, which is HW over TW is 44.11, is lower than the given is 66.24. Shear buckling resistance pass. And then step number 6, flange buckling resistance. Okay, is also pass, because the value of HW over TW is lower than the value of flange induced buckling, 301 and 95. Step number 7 is web buckling resistance. The VED must lower than FRD, and the result is pass, which is the VED is 62.88 kilonewton, is lower than FRD 234.04 kilonewton. So the web buckling is pass. And last one is deflection. Deflection, I've got the S actual is 15.24 millimeter, is lower than S allowable, 22.22 millimeter. So deflection pass. Next, I go to the steel column design. Okay, for the determination of design load, MED, it come from the roof truss and plus with the beam load. So the NED is total NED is 126.64 kilonewton. And then for selection of section, I've got the size of the column is 152 times 152 times 30. This also refer to the catalog that we search, and the area is 38.3 centimeter square. Okay. And then step number 3, I specification of section. First is web section. I've got that web section is class 1, and French section I got that class 3. So I take the larger class to determine the column section. So the column section is class 3. And then number 4 is determination of design edge compression, NCRD. The NED must be lower than NCRD. Okay, the result I got is NED is 126.64 kilonewton, is lower than 1359.65 kilonewton. So the compression resistant pass. Number 5, step number 5 is determination of nominal buckling length. For this part is I assume as intermediate grease strain column, which is the beam is connected with the column, so it is easier for steel connection calculation. Okay, and then number 6 is determination of design buckling resistance, NBRD. NED must be lower than NBRD, so I calculate for YY axis and ZZ axis. For information, we must design for the YY axis because it is the weakest axis. So if the YY axis pass, then ZZ also pass. Okay, so back to the step number 6, NED I've got for YY axis is 126.64 kN, is lower than NBRD, 767.94 kN. So pass. And then last one is ZZ axis. NED I got same 126.64 kN, is lower than 487.47 kN. Also pass. So I pass to Takyudin for steel connection.
Okay, I will present about the steel connection. Okay, for the dimension that has given from Said, which is the dimension for beam is 305 times with 102 times with 33, and the dimension column is 152 times with 152 and times with 30. So I search for the catalog that for bolt and nut and the steel plate. And the bolt and nut that I get is the non-preloaded bolt, property class 4.6 hexagon head bolt with S420 with diameter M12. For the number of bolt I determine is VED, which is I get from the column NED column. I divide by the FBRD, which is have been given at the catalog of the bolt and nut. So after I divide the calculation, and I get the 8 numbers of the bolt. For the E1, E2, P1 and P2 is given by the catalog, which is the E1 actual is 25, E2 actual is 20 mm, P1 actual is 35 mm, and P2 actual is 40 mm. And after do the calculation, for the minimum of the E1 is 1.2 D naught, where I get the D naught is 1 mm is for M12. I plus with the 12, which is 12 is diameter of the bolt, and the class of M12 we must 1 plus 1 mm for the clearance. For the D node is 13 mm, and the distance for E1 minimum distance is 15.6, same as E2. P1 is 28.6 and P2 is 31.2. And the maximum for the E1 is 72. Maximum for E2 is 72. Maximum for P1 is 112 and maximum for P2 is 112 too. And for all the position of work is passed. And for the load capacity, which is by using the formula alpha V times with FUB times with A over the gamma M2. I search for appendix and get the FUB and the gamma M2. FUB I get is 400 and the gamma M2 is 1.25 and alpha V is 0.6. For the area A, I get the 113.10 time with 8 volt, and I get the 173.72 kilonewton, which is bigger than the provide VED of the beam. Why I choose VED beam? Because the end plate to connect the beam and the column. So the VED for beam need to choose for the comparison. For the bolt bearing resistance, same as the calculation that has been teach by the lecturer, which is we need to determine FBRD. For FBRD is K1 times with alpha B times with FU times with D and times with T divide with gamma M2. For the FU, I have been referred at the appendix, steel appendix design, which is 520, and uh, after during the calculation, alpha B I get the 0.64 and K1 I get 2.61. After do the calculation, type with 8 volt, I get 533.67, which is bigger than the 62.88 for the VED of the beam. So bolt bearing resistance is passed. After that, step I next uh, I do the calculation for the plate check. Plate check is pass to, which is the plate check shear resistance. I get the 197.91 is bigger than the 62.88 for the beam for the VED for the beam. And the block tearing for the plate check is 168.42, which is bigger than 62.88 kilonewton for the VED beam. And after that, I calculate for the beam web check. I get the 248.06 kilonewton, which is bigger than 62.88, also pass. And the welding check is 282.45 kilonewton, bigger than 62.88 kilonewton, which is pass too. For the welding check is pass. And some of the value I get for the FU, FYB, and FUB, I refer to the appendix, and both I refer to the catalog that I have searched to. That's all for the steel connection, and I will pass to Ama for the AutoCAD progress.
Assalamualaikum. My name is Muhammad Amar Zakam bin Muhammad Hanif. So from all the calculation, I get to design the the drawing for in 3D. At first, I made the column first. After that, I made the beam, and then I made the slab thickness to determine the next column for the middle. After that, I made the truss of roof. So the size of column and beam from the general is one for column 152 times 152 times 30. Type of steel is UKC. For size of beam 305 times 102 times 33. Type steel is UKB. For the specific for column and beam, for H, column 157.6. For B, 152.9. For TF, 9.4. TW, 6.5. Radius for the angle is 7.6. For the beam, H is 312.7. B, 102.4. TF, 10.3. TW, 6.6. R, 7.6. So from the front view of the design, we can see height of column is 8 meter, and height of column middle is 4 meter. Length of truss of roof 16 meter, and each truss uh, each truss length of each truss is 2 meter. For the side elevation, it has 4 slab, which each slab 5 meter. For the connection, we can see from the calculation Taki, we can see for E1.
For the 20 is E2 and 35 is E1. Wait. Okay, for the E1 is 25. And the E2 is 20 mm. And P2 is 40 and P1 is 35.
So the general of type of bolt is M12, and size of M plate 150 155 times 80 times 8. Okay, that's all from me. Thank you.
So, as a conclusion, this mini project have taught us how to calculate or design the steel truss, the steel column, and steel beam. So this will help us for our future as an civil engineering to produce to be a better engineer in the future. So I think that's all from us. Thank you, and I hope we will meet again soon. All right.
Thank you.